This is my 5th video on physics equations, and it's about waves in strings, waves traveling through strings. For example, a guitar string. If you pluck a guitar string, then what happens is that waves whiz up and down the string. The string vibrates as waves are traveling through it, and it makes a beautiful noise. And we can use this equation, V is root T over mu, to work out the speed of the wave traveling in the string. V is root T over mu. T is the tension in the string. It's how tight the string is. T is the tension in newtons. V is the speed of the wave. Mu is the mass per unit length of the string. Kilograms per meter, the mass per unit length. Okay? Now, one thing to be careful with, if you are given the mass per unit length in grams per meter, that won't do. You have to change it to kilograms. And 1 gram is 1 times 10 to the minus 3 kilograms. For example, if it said the mass per unit length was 3 grams per meter, then on your calculator you put 3 times 10 to the minus 3. Okay, it has to be in kilograms per meter. Usually it will give you it in kilograms per meter, but just in case. The other tricky thing about this equation is working out the square root. I doubt very much you're going to have to rearrange this equation. You'll be given the tension, you'll be given the mass per unit length, you divide the tension by the mass per unit length, and then you get the square root of that. To get a square root on a calculator, there's a button on your calculator which is x to the something, x to the white square. If you put x to the 0.5, that will tell you the square root. And in fact, that's how I always work out the square root on the calculator. So work it out, put it to the power of 0.5, and that will be your answer. Let's do this one together. A guitar string has a mass per unit length of 0.401 times 10 to the minus 3 kilograms per meter. The tension in the string is 71 newtons. Calculate the speed of the wave. So I don't need to worry about the mass. It's given me it in kilograms per meter, so I don't need to change it. So I just bung in the numbers, get the square root, and the answer I get, 421 meters per second. Here's a sum for you to do, and the answer is this. Okay, note that this time I had to say 2.33 times 10 to the minus 3 because they gave me the mass per unit length in grams per meter, which is very sneaky. Okay, and the answer is 188 meters per second.